This is a really large version of a game called Connect 4 here in the United States. I don't know if it was invented here. You may know it by a different name. It probably looks a little more like it was made in or invented in China, but who knows? Who cares? In any event, you can imagine making, or at least I can imagine making this game for my grandkids to play outside in the backyard and have fun. They could all get involved. The goal is to get a certain number of your color uh, circles laid out in the right direction. I think it's either up or to the right, and then to block your opponent. Now, if I were to start cutting this and I did not plan ahead, I would have, as you can see, two separate sides of a piece of wood, which I could view the discs that I drop into the game to play. But those circles would not have a mark for the center. Now, that can be a little problematic if you want to use those circles over and you just didn't plan it. It's also possible you could go down to your local home improvement store like Lowe's or Home Depot and purchase some of the wood discs that they sell there that are used for like bar stool seats or nightstand tops or even big enough. I think there's some 36-inch ones that you can make a coffee table out of. And if you wanted to put some artwork in the very center of that, then you need to know how to find the center. So today we're going to cover Talus theorem. Talus theorem is a geometry theorem that describes in detail how you can determine if a triangle is right when it inscribes a circle. A side effect of Talus theorem is that you can also figure out if your lines go through the center of the circle and then mark that point from there to proceed with your CNC. So without further ado, we'll go ahead and go from there. Talus theorem looks like without going into any mathematical or geometrical proofs, which I guess technically speaking are mathematical. So let's draw a circle here, and it doesn't really matter what the diameter of the circle is. So let's just make it big enough to view. And then let's come over here and let's draw some lines on this. Okay. So if we look here in Autodesk Inventor, we can see that point is snapped at the 90-degree angle, or excuse me, is tangent to the line vertically right there to the circle. So if we start one right there and we come up here, we get another snap there. And then we start another line and we come over here and we snap there. Okay, and now we run one last line over to the other point of the circle, of the triangle, excuse me. And there we go. All right. So what we have is a triangle that is inscribed inside the circle. What Talus theorem says is that if you have a triangle that's points inscribe the circle and the hypotenuse of that triangle is the diameter of the circle, then that triangle is a right triangle. Now, as I pointed out, I think earlier, there's a side benefit to this for us as woodworkers, and that is that it helps us find the exact center of a circle. So let's go over here and let's look at this, and we'll draw some more lines and see how this works out. Let's go ahead and start at the same spot, and we'll go down this time. And now we're going to go straight up, and we're going to connect to that point. Okay? So we click on OK, and we can see now that what we basically have here is a square, kind of. Let me go ahead and draw a line just so I can say that we have a square there. Doesn't really matter, but I'm doing it anyway because I'm obsessive compulsive. So now we have our square inside of a circle. Okay. Now we know that if we wanted to find the exact center of a square, we would just draw lines that bisect the angles on opposite corners of the square. And that would give us the exact center of the square. Well, as it just so happens here, we have, actually have a couple of right triangles here. We have the right triangle that's this one, and this one. And then we have the right triangle that's this one, and this one. sides, excuse me. I should be more mathematically correct here for a guy who's got graduate studies in math. I sure forgot a lot of that quick. So in any event, now we come down to the center of the circle there, and we can see that, wow, okay, we found the center of the circle. So now how do we put this or apply this, put it to work in the real world? Well, if you can imagine, this line right here is one side of a right triangle, and this is another side of the right triangle. And this is the right triangle that you use in your shop every day for drawing right angles and straight lines and all that sort of stuff. If this were the very top of the right triangle, and then this was a point that extended past and this extended past, then all we'd have to do is put a mark here and a mark here, a mark here and a mark here, draw lines through each, and boom, we've got our center. So it's pretty handy, and I'll show you how it's done with a real right triangle in probably a crude and sloppy fashion. I try not to be that way, but sometimes that's just the way it works out. And hopefully you'll get something useful out of this, and then when we're all done, we will see how this can be applied to using really inexpensive wood that you can purchase down at your local home improvement store to make some really cool stuff. And it's easy to do, and I enjoy doing it. Maybe you'll enjoy doing it too.